Hello and welcome to this episode of This Is My Architecture. I'm Kapil and with me I have Girish from Eyeota. Girish, welcome to the show.
Thanks, Kapil. It's good to be here.
Glad to have you. And Girish, can you tell us a little bit about Eyeota?
Eyeota is an audience data marketplace with a global footprint. We provide a privacy-compliant way for advertisers to reach their target audiences with precision and for data providers to monetize their data with transparency.
And Girish, you have built a new data platform on AWS. Can you tell us what were the challenges you were trying to solve?
The primary business problem we're trying to address is data quality. We are certified by both the IIB Tech Lab and by Neutronian, the gold standards in ad tech data quality certification. The way we achieve this quality is by using our machine learning algorithms, which are designed to optimize the trade-off between scale and data quality. In technical terms, it translates into a few different requirements. One is scalability, given the volumes of data we process, flexibility for our development teams, abstraction from the infrastructure layer, and transparency on unit cost economics, so that all of this comes together to increase delivery velocity.
Great. And could you walk us through the diagram? I see a lot of moving parts here.
Sure. So this is really, you can think about it as the model lifecycle, and we articulate that in code in the form of Airflow DAGs, PySpark scripts, and Sagemaker notebooks. We also have our raw data, which comes to us from our supply side partners. And both of these we store in S3. From S3, we use Airflow to pick up, orchestrate our data pipelines. So this, when it goes into the top over here, essentially what's going on is we're using Glue for pre-processing and feature selection. That's where the PySpark scripts come in. From there, the data flows into Sagemaker for model training and tuning. And also from here, data flows into Sagemaker batch inference, which is where we run, which we run on our held out data sets.
Right.
Down here on the inference side, again, Airflow is triggering a pipeline with Glue doing pre-processing. And from there, the data is going into Sagemaker for batch inference. Remember, this is on unlabeled data. So the generated labels are then stored in S3, from where it is distributed downstream to the rest of our pipeline.
Okay.
And in the middle over here, we have model selection and pipeline optimization. So both of these pipelines, they push their performance and operational metrics into Cloudwatch, from where we have an internal metrics visualization tool, which we run on EC2, that helps our data science teams figure out what is the right model to push into production for each use case. The selected models are pushed into S3, and that's what is used by the batch inference job to run on the production workload. Our data science team also use the visualization to monitor the production pipelines for things like model drift. At the same time, our data engineering and infrastructure teams, they also use the metrics over here to ensure pipeline uptime and also look for optimization opportunities.
Right. And I can see there are clearly two different types of pipelines here. Can you tell us what's the typical scale of data processed by these pipelines?
So up here for model training and tuning, we run a few hundreds of training jobs, each of which is processing anywhere from a few hundred megs of data to a few hundred gigs of data. Down here on inference, we run a few hundred inference jobs, each of which is processing terabyte scale data. Ultimately, we are processing like 6 to 7 billion unique advertising IDs a month and mapping these into 70,000 different attributes. So all of this is running on a ginormous distributed sparse matrix.
Fantastic. And you're doing all this orchestration from Apache Airflow. Can you tell us why Airflow?
Primarily, it gives us a lot of flexibility for both our data science and data engineering teams. So typically, a data science team needs to work on very experimental features, and they can do that on Airflow. But the data engineering team is optimizing production scale performance, so they can do that as well on Airflow. So it's a single platform that both of them can use, and it's great for our velocity.
And what was your experience like integrating from Airflow with AWS services?
It was quite straightforward to orchestrate the services. It was mostly a question of following the docs. But then when we got into finer grained configuration, we faced a bit of a learning curve. For example, we needed to figure out the right metrics to monitor here so that we could figure out how many DPUs to process for Glue, to configure for Glue. For Sagemaker, we need to play around a bit with distributed learning and model averaging to get it to scale to our sizes of data.
Right. That's a lot of fantastic work done by your team. What would you say are the key outcomes of this project?
Team efficiency. I mean, it's right now we get most training jobs, training pipelines configured within 3 to 5 working days, which is half of what we used to do earlier. And we get this with a lot more transparency on model performance and also a lot more configurability across the board. So it's a huge win for the team.
That's fantastic. Girish, thanks a lot for sharing all these insights with our viewers. And thank you for watching this episode of This Is My Architecture.